multiplier means you apply less effort, you are able to move a heavier load. So that is acting like a force multiplier. The second thing that is available is uh, gain in speed, or which is also called as speed multiplier. That means you are able to do work at a faster rate. Do you follow that? Okay. So that means you can do things faster. Now here, if you have, if the example for that was a scissor. In a scissor, you're able to cut things at a faster rate. This is change in direction is an example was of a pulley. So in a pulley, you are pulling it down. Okay, so you are pulling it down and the object is moving up. Yeah, change of point of. Now in this, I gave you an example of a bicycle. I'll show you again to understand that how is the change applicable. Like here, this is a pedal. Now on the pedal, you apply effort. So the effort is applied in the downward direction on both the pedals, okay, when you're seated over there. But this effort get applied on the back wheel. So you are applying effort on the pedal and it gets applied over here. And this wheel is able to turn. And because of the turning of the wheel, okay, what do we get is motion. The bicycle moves ahead. It is easier for the person to sit over here and pedal it rather than sitting on this back seat, okay. So the first term is effort. Now effort is denoted by a letter capital E, and the unit of measuring effort is Newton. So whenever you are using a machine, that the force that you apply is called as an effort. Then you have load. Load again is a heavier, or it is called like a resistive force that the machine has to overcome. So any heavy mass, any heavy stone that has to be shifted. So load is also measured in Newton. Okay, like in the case of a pulley diagram over here, this person is pulling the pulley down. So the force that he applied is called as effort, and he is raising this weight up. So that is called as a load. Then there is another term called as mechanical advantage, defined as a ratio of load upon effort. Okay, so that is how you define mechanical advantage, load upon effort. Now we see that the load and the effort both are measured in Newton. So mechanical advantage will have no unit. It is a pure ratio, velocity ratio. Now velocity ratio is defined as velocity of effort upon velocity of load. Okay. Now what is velocity? Velocity is distance upon time. So that is displacement of effort upon time divided by displacement of load upon time. Okay, I'm writing it over here. So this is displacement of effort and this is displacement of load. Now when this changes into multiplication, the division of effort upon displacement of load. Velocity ratio has no unit. It is a pure ratio. And this is work done by the load. One quantity which we have seen in various numericals before, that is efficiency. And efficiency is denoted by this Greek letter. And efficiency has a formula that is work output upon work input into 100%. This is expressed in percentage also. So efficiency is work output upon work input. And we saw work output is load into displacement of load. And this is effort into displacement of effort. Now this is load upon effort divided by displacement of effort upon displacement of load. Load upon effort is MA and displacement of effort upon displacement of load is VR. So this is the relation, or MA is VR into efficiency. So this question has come previously in the exam for 3 marks. Or the work that you do is 100 joule in a machine. If the machine can give you 100 joule out, so that will be an efficiency of 100%. Now over here, what I'm trying to tell you is efficiency of machine means what? That if you put in some effort, how much gets out? How much does the machine do? So what I'm saying is, if you are giving 100 joules and the machine is able to give out 100 joules, that means the efficiency is 100%. Now, this is only in the case of an ideal machine. In a practical machine, less than work input. And in a practical machine, the efficiency is less than 100%.